I wanted to have a system to look at powder diffraction at low temperatures. Now, the only commercial apparatus at that time that was available was made by a company called NRF Nonius. That was the main company of it. It was a horrible beast. It was made out of glass, so it was very fragile. It was a real Heath Robinson piece of equipment. It used liquid nitrogen, but it was very, very unstable. And so you had to have dewars and multiple dewars and things to get it to work properly. You were lucky if you could get down below 150 Kelvin with a precision of maybe plus or minus 30 degrees, something like that. Often liquid nitrogen all over the place. And when the dewar was expended, then you had to refill it, so you lost the pressure, and it was an utter mess. The result was that crystallographers who had wanted to do low temperature crystallography for years hardly ever did it, because it's just too much
too much hassle.
Too much fluff. Yeah. So I wanted something better than that, and we had in the lab very good low temperature laboratory, and one of the guys who ran that, who was a technician, or what we call a research support staff, John Cozier, was an expert on cryogenics. So I approached him with the problem, explained what we need is an open stream cold nitrogen gas which is stable, which you can believe the temperature on it. And he went away and he came back with an idea, and the basic idea was that unlike the old system where you had a sealed dewar and you put a heater in it and you boiled off liquid nitrogen and the gas then went through a pipe over the crystal, you can see that if you break the seal you use the pressure and temperature goes all over the place. So he came up with a different idea. He designed a system where you had an open dewar with liquid nitrogen in it, and then a capillary pipe inside it, and you suck the liquid nitrogen into the capillary pipe, which had a vacuum jacket around it, into a heat exchanger. And when it enters the heat exchanger, this cold liquid nitrogen is heated, turned into gas, comes out of the heat exchanger through a pump, and then back to the heat exchanger, by which time it's now near room temperature. Now you have the room temperature gas on one side of the heat exchanger, and the other side you've got the cold liquid. It's cooled again. And then that cold nitrogen gas then goes out through the nozzle, and you have another heater which allows you to heat up that cold gas to any temperature you want. So we built a prototype. Because the dewar is not sealed, meant you could refill it any time you like, no pressure difference between the inlet and the outlet. And we built a prototype which was about 1 meter long and tried it for the first time, and it astonished us because suddenly we could go down to liquid nitrogen temperature with an error of 0.1 degrees. And I said to John, I think this is important for crystallographers. So I then said to him, we've got to make this smaller, because my idea was to make the system so that it was portable. So you could put it on a diffractometer or on a camera, wherever you wanted to have a cold stream of nitrogen. So he redesigned it, and we worked on that to get it small enough, and we called it the Cryostream. Called the head of department in, Bill Mitchell, to see it. He said, it's very clever, don't think there's any money in it though. So I said, Bill, do you mind if we set up a plant in the basement here, see whether we can market this? He said, yes, go ahead. Those are the days when the university wasn't interested in this kind of thing. Today, you'd have to have patents, you'd have to have lawyers involved, you'd never get there. We probably would never have started. But in those days, it was free and easy. So we built a couple of them. And at that time, one of the representatives for the Stowe company in Germany, David Brown, came through. He was a salesman who was very well liked in this country. He came through and he saw it. He went away. And about 3 weeks later, he came back and said, I've got a customer for you. And that's Paul Wraithby in the chemistry department at Cambridge. And Paul was prepared to pay us the money up front. The result was that we were able to work. We never had to take a loan. We always had cash, always cash rich in this business. So we built that first one for him, which, by the way, is still working. So we're talking about 1982, something like that. He then recommended it to Bill Clegg in Newcastle. And then the next one came an order from Germany. We had a problem in Germany because the control unit we were using was a BBC microcomputer. That's what we had at the time. And in Germany, they said, we don't support BBC micros, we can't do it. So we put the BBC microcomputer into a box and called it a temperature controller, and then they were happy. So that's how we started. And a great advance happened at this point in the field of protein crystallography. They'd had a problem always that protein crystals don't survive very long in the X-ray beam, which made it very difficult to collect their data, because they had vast amounts of data to collect. But it was discovered that if you flash cooled the crystal and kept it cold, it survived indefinitely in the X-ray beam. And everybody in protein fields, the people who had the money, wanted to do this flash cooling. And we came along with this device, and sales took off exponentially. So we then bought a place out in northwest Oxford, put our own plant there, and went into business, initially as a partnership, later as a company, marketing the Cryostream, and then later other variants of this. Some years later, we sold the business, so we made a lot of money out of that, but we carried on. We were owned by a private equity company at the time, which was not very satisfactory because it made it very difficult for us to innovate. Eventually, we managed to buy the company back for much less than it was worth. And so we then carried on the business, developing it. And we had money, for partly a loan from me, partly a loan from the bank, partly a loan from a venture capitalist. And last year we sold the company again. Classic, you know. So we did very well. And it's a thriving business. We are the sole distributors of low temperature apparatus to crystallographers around the world. And it's a surprisingly big business. I don't know how many Cryostreams we've sold now. It's several thousand around the world, going out at about 15 to 20,000 pounds each. And we branched out into other areas. We have another area now. We're working on the detectors for the square kilometre array, which are these vast arrays of telescopes, radio telescopes in South Africa. And they've got at the centre of each disc, they've got 3 detectors, and each detector has to be separately cooled. So we provide the cooling devices for each of those. So that's a multi-million-pound order.
Wow.
Over the next few years.
Wow, fantastic.
So that's been a way we've sort of branched out. So it's been a very, very successful business. And in the crystallography community, we are very well known, very well liked.
I've seen your Cryostream systems in various laboratories around the world.
I get a great kick of walking into a lab and seeing a Cryostream. We have no competition now. We did have for a few years, but we've seen them all off.
Yeah.